I think he would have written also a sequel, such as Science in a Spaceship and the Art of Eating Well, in a very different environment. And tonight's theme, indeed, as you all know, it's food in space. Science, technology, and taste is exactly the point where knowledge and science are essential to guarantee the support of life of humans, both in space and in the future human colonies that one day may be established on the moon and eventually on Mars, who knows. The exploration of space with its industrial and technological fallout and application and its economic and social benefits is one of the Italian national strategic priorities. Throughout its national programs, bilateral cooperation and participation in international projects, Italy is one of the very few nations who have a space and aerospace sector characterized by a complete supply chain of products and services, including a very strong industry of food in space. I don't want to spoil too much the following of this discussion, but that's exactly true. And the Italian industry of food in space already supplies the International Space Station. Australia and Italy are already working together in several fields of research and are important industrial partners in the field of space. In May 2017, Italy and Australia signed an agreement at the level of a treaty for scientific and technological cooperation and innovation. The two space agencies, the Italian Space Agency and the Australian Space Agency, are now negotiating an agreement regarding the International Space Station partnership opportunities. And maybe tonight we are opening another field for future cooperation. Before leaving the floor to our distinguished speakers, I would like to send a special greeting to the students and teachers of the Istituto Ciampini Boccardo of Novi Ligure who are following us via Zoom. Thank you very much. Welcome all of you, and please enjoy the evening.
Thank you, Ambassador, for your introduction. And before shifting to each individual speaker, I would like to introduce briefly all of them, just really by the name. So we have Stefano Polato, in the order in which they appear on the screen, not in the order in which they will be speaking. We have Stefano Polato, our star cook, who will talk us.
Good evening, thank you.
How it's working. Alberto Battistelli, a colleague from CNR, National Council of Research. Then we have the engineer Paolo Nespoli, our astronaut, and Lilia Ravagnolo, working also on research on science, food in space. Now I will call Alberto Battistelli to begin, and so I think that all the other will shortly disappear, or they will stay. What do you mean? Well, we can stay like this, but if he has to share the video, then, well, okay, they will share it. So we will begin with Alberto Battistelli, who is an agronomist and plant physiologist at the Italian National Council of Research, which is something like your CSIRO here in Australia. And he will discuss on how much science and technology is required in supporting space travelers and in providing food for future Moon and Mars human colonies. He will also discuss how much of what we learn in these researches can be applied back to Earth to improve efficiencies and circular economy. Dr. Battistelli, please, the floor is yours.
Thank you. Distinguished guests, Her Excellency Ambassador Tardioli, good evening. And buongiorno a tutti gli studenti che ci stanno seguendo da Novi Ligure. I have to talk about, and it's a real honor and a pleasure, about science and technology for efficiency and circularity of health food production in space. I am first researcher of the National Research Council, which is the largest public research body in Italy. It's organized in 7 departments, 90 institutes, and more than 7,300 scientists, which are covering all science areas. My institute has a headquarters in a small region in the center of Italy, which is the region Umbria. We are close to a well-known town, which is Orvieto, and here you can see our seminar room. So we have quite deep historical and cultural heritage that we have to connect with food, and Orvieto is well known for its wine. But we have to talk about space. So space is a dream since ever, and now the dream is actually planned with the rationality of our technological and scientific heritage and ability. Here you see the last new on the space area is the initiative Artemis from the United States, and these are this initiative is already planning for having some stable base on the moon. This is called the Foundation Surface Habitat. This is nothing similar to what can imagine for a manned base, but the path is already on the way. We have more or less three main scenarios when we talk about manned men in women in space. And the three scenarios are manned bases on the moon, transit vehicles, so long journey in space, and manned bases on Mars. But we know that, as I wrote in the introduction to this event, traveling in space is difficult and expensive. Luggage can be too heavy nor large. That means that we can do in the future what we do now, so traveling back and forward from the Earth to resupply the International Space Station. In the future, very likely we will have a solution to that will be to build bioregenerative life support systems. These are artificial closed techno-ecosystem, including autotrophic and heterotrophic organisms, and they should ensure a complete recycling of resources. Functions of these systems are in situ resource utilization. So when we arrive on the moon, we should be able to use what we find there. We don't find very much, but what we find will be very useful to reduce the amount of stuff we have to carry from Earth. In situ resource production, and this is precisely, for example, producing food there, high efficiency and circularity are a must in these conditions. Italy has a long tradition on this area of technology and science, thanks to the coordination of the Italian Space Agency. And we are organized even in a working group, which is called Italian Bioregenerative Systems, and includes the academy and the industry. In space, it's very important to have international collaborations and tight collaboration between the academy and the industry. The idea of the bioregenerative life support system is to have different compartments. This is a cartoon from the European Space Agency initiative Melissa, and you can see shortly that what we are thinking is just to be inspired by the Earth ecology, and then we need the primary producers. They have to photosynthesize, fix CO2, produce oxygen and food. Higher plants are the best candidate for that. But we also have recycling of waste, of course. Now, we are used to food. This amount of vegetable, I could buy them on a neighborhood shop in 15 minutes. Can you imagine how difficult it would be to have all that stuff in space and to grow them, to be able to provide them to the astronauts? Our topic is use the environmental control to guide the plant-environment interaction and obtain high nutritional products. Plants are an incredible laboratory. They produce the main nutritional compounds like carbohydrate, protein, and fat, but they also provide a lot of many other compounds like antioxidants, vitamins, and we are focusing on prebiotics. We should be careful. They can have also negative compounds, and the control of the environment also helps to reduce that. Past project, our experience started with even with experiments on the International Space Station, but I suggest you to check on the internet site of this project called Eden ISS, which was running between 2015 and 2019 with an international consortium funded by the European Union or Horizon program. And what we have done was to plan, build, test, and transfer to Antarctica of this facility. Italy has built most of the hardware of the system, and you see that we had also interested entities there. Just to understand the complexity of it, this is one of the subsystems, the air management system that was built by an Italian company, planned and built by an Italian company. This compartment here is called Future Exploration Greenhouse, and these are shelves where we grew plants for almost 1 year in Antarctica. This is the internal part with different types of plants grown there. We obtained more than 280 kilos of plants or vegetables in a little bit more than 12 square meters. But the important point is also the possibility to have bioregenerative fluxes. You see here, these are the control systems, trace of the CO2 concentration in the greenhouse. These are the set point, so the baseline in spatial terms. And you see at night, CO2 is increasing because plants are respiring. When light goes on, CO2 decreases because plants are photosynthesizing and fixing CO2. And then what's that green spike here? This is when our friend Paul Zabel entered the greenhouse to do some work, producing CO2. Then he went out for lunch, and plants could decrease the concentration of CO2 inside. This shows how the control of environment can tell us what is happening, and also tells us that 12 square meters were not enough to consume the CO2 produced by Paul Zabel in his work. We also could check food quality modulation by light. So we grew lettuce for 4 weeks. When they were ready for harvest, we increased the light intensity for only 3 days, and you see we increased a lot starch content and in general the non-structural carbohydrates. These include sugars, which affect quite nicely the taste of lettuce. So again, controlling, this experiment was performed in Antarctica. Samples were taken there, frozen, and brought in the frozen state from Antarctica to Bremen there, and then to Italy. So quite a long journey for these frozen samples. And then, yes, we can control quality and even taste by technology. There is a new project in Italy. This is called Rebus, and it's granted by ASI, again, the Italian Space Agency, again, quite large consortium, fully Italian in this case, in which we have large and small industries like Thales Alenia Space, Telespazio and Kaiser, and also universities and also the CNR. We know that we are not alone when traveling in space. Our microbiota is with us. A microbiota is a large community of microbes which is inside us and on us, and we have to be able to interact with them in a positive way. We can do that via prebiotics. A prebiotic is defined as a substrate that is selectively utilized by the host microorganism, conferring a health benefit. And we know that prebiotic can affect our good microbiota and producing effect on our brain. So our final aim is to produce prebiotic in space, in BioLSS, for astronaut well-being. Just a short result, in fully controlled environment, we could increase light intensity again and produce more prebiotics. This is the case of a traditional plant for Italy, is Sycorium mitibus. So we could modulate the amount of prebiotic, in this case fructans, by acting on the light intensity. And so conclusion, the first one is that I wish I am 20. And this is because this is a work for young people to complete. And for that, it's very important that university have a central role in activating space-oriented courses. I am also convinced that there is no contrast between food quality and technology if solid science support the effort. Then the Italian know-how and traditional ability or good and health food, my health, future space travelers, and also good nutrition on Earth, I would add. Space science can help reducing the negative impact of agriculture on Earth while ensuring more reliable and efficient food production. This point it's an important one. We could speak on that for hours. Just a number, we only use 10 liters of water to produce 1 kilo of vegetables, which is a very tiny fraction of what is normally used in agriculture. We didn't use pesticide, and we could plan precisely the data of harvest, so very little or no waste. So I'm convinced that plants are and will be part of our wonderful world, either on Earth or in space in the future. This picture is a picture of a small town in central Italy, Castelluccio di Norcia. I took this picture just a few weeks before it was unfortunately destroyed by the known earthquake. So we need to take care of space, and doing that, we need to take care also of Earth. Thank you for your attention.
Well, thank you very much, Dr. Battistelli, for your insight on this very fascinating subject. And now I would stop to say two important things. One is that I wanted to take as a surprise the presence of Paul Scully-Power, but seeing that all people are there and you can't see him, I would like to introduce him too. And so we have the honor of having him here today with our Italian colleague. So thank you very much for coming again. And the second, very, very, very much less important thing, but still important, if you want to put questions on the webinar, you can type, and then at the end we will select some of the questions you are putting. Now, after Dr. Battistelli, I'm very pleased to introduce Dr. Liliana Ravagnolo. Liliana Ravagnolo is a technical instructor for astronauts at the International Space Station, and she is the Mission Operation Training Manager within ALTEC. ALTEC is an Italian company dedicated to aerospace, logistics, and technology engineering that is deeply involved in the ExoMars 2022 mission. Dr. Ravagnolo collaborates in the project of production and management of the so-called bonus food for the astronauts, also in cooperation with NASA Food Lab, with the Russian Institute of Biomedical Problems, and with the design chef for the production of space food in several missions. Among which, there is the VITA mission, a mission during which the astronauts Paolo Nespoli completed more than 60 experiments. So Dr. Ravagnolo will explain us what happens when the Italian cuisine goes to space. Liliana Ravagnolo, yours.
Thank you. And good evening, distinguished guest, Her Excellency Ambassador Tardioli. Good evening, everybody. It's really an honor for me to be here tonight to explain to you how the Italian cuisine goes to space. I thank you very much for the invitation. Buongiorno a tutti gli italiani connessi in questo momento. As it was said during the introduction, I work for a small Italian company that is called ALTEC. ALTEC is the Italian Center of Excellence for the provision of services for the space station, but not only. So we work in several fields, and we are owned by a private-public company owned by Thales Alenia Space and the Italian Space Agency, ESI. We are involved in several fields in the space activities, as you can see in this slide, mainly related to ISS, support to ISS and human space flight. But also we are responsible of the center of control of the next ExoMars mission, the rover that the European rover that will go to Mars in 2022. We have several projects related also to satellites, and we are involved in new space economy activities. But we are here to talk about food. So let me show you some images that were taken during the Vita mission, the Volare mission of Luca Parmitano, our Italian astronauts. And the scope of this is to explain to you how the food is managed in space. First of all, there are two types of food, the standard food and the bonus food. These images are showing mainly the standard food that is produced by NASA or the Russian Space Agency. And you can see in the images on the bottom side how the food is preserved. Because we have a very strict requirement of conservation. So the food should be eatable for 24 months. And this is not very easy to maintain. So the two main ways that are used are the dehydration. You can see here some dehydrated food on the left side. And I can tell you that these are strawberries, these are eggs, and these are shrimps. Obviously, all the water has been removed, and then when they will be consumed on space, the astronaut will have to introduce water through an adapter that is shown here, is very small, and they can add cold water or warm water, it depends on the type of food. And then after leaving the food for some minutes to restructurate the consistency, it can be eaten. On the middle area, we have thermostabilized food. Thermostabilization is used mainly for pasta or meat, sausages, and it consists in preparing the food, packing it in pouches that are made by aluminum, like the one that you see there. Then they are put at very high temperature, very high pressure to destroy all the possible bacteria. And this will allow to maintain the food for 24 months. This type of food is just warmed up in the oven. Then we have the beverages that we can see on the right side. It is important to know that on board only soft drinks are allowed, so no alcohol, no wine. And the type of drinks that are available are like coffee or tea or juice fruit. Also in this case, they are provided in powder. The astronaut can add warm water, cold water, depends on the drink, and then they are eaten. They drink using a straw. It's very important to avoid to have fluids drops that floats around due to microgravity. Last information is about fresh fruit or vegetables. In the past, it was easier to provide to the astronaut fresh fruit and vegetables because the shuttle, for example, was possible to load up to 24 hours before the launch. Now this is not possible with the cargo that are used to send the food in space. They are loaded several months before. The only one that allows this is the Progress. So crew receives fresh fruit and vegetables only very rarely. This is the standard food. Now let's have a look to the bonus food. Bonus food is provided by the local agencies that are sending astronauts on board. And it is produced normally by the nation, the country from which the astronaut comes from. And it represents typical recipes of the cuisine. We have been involved by the Italian Academy of Cuisine in 2007 to send the first Italian food to astronaut Paolo Nespoli during his Hesperia mission. And we worked with several Italian producers to provide a meal that is shared with its colleagues. And we repeated this experience. Here you have a picture of another mission of Paolo Magistra with his friends, his colleagues. And here we have Volare mission, Luca Parmitano, again sharing the Italian meal with his friends. On the bottom side, you have examples of what we provided, several types of pasta, sweets, and chocolate. Chocolate was very much appreciated by the crew. And they organized, for example, tasting session where all the colleagues were allowed to taste the food and then help the astronaut in selecting the better one to share. So Altec has a long experience in that and is also responsible of managing the provision of European food for European astronauts, not only Italian. So here we have some examples. We are in contact, sorry, this was the movement of the mouse. We are in contact also with the chefs that produce the food. So in the top side, you can see Heston Blumenthal that produced the food for Team Peak, and Torsten Schmidt, who produced the food for Andreas Mogensen. So we are responsible also for collecting food provided by other companies and sending it to NASA or to Russia for sending on board. Last information I want to provide you, we are also working on future ideas. So you have heard from Mr. Battistelli that there are projects going on to build up some greenhouse to produce fresh food for astronauts. These are very, very interesting and important projects. But as you can imagine, before you will have a greenhouse able to sustain a crew of 6-7 members, it will take time. So in the meantime, we are studying the possibility to use 3D food printers that are working on cartridges with ingredients that are provided in lyophilized way. So the 3D food printer has a recipe that are loaded in, and it can produce the type of food that the astronaut wants to taste for that day. There is a little psychological aspects related to that. There is a possibility for the families, for friends to send up, to load new recipes that can be used for birthday, for Christmas, for Thanksgiving. So just to give a little bit of psychological support also, you have to imagine that astronauts are going to live outside Earth in the exploration mission for months, for even years. We think to a mission to a moon or to Mars, it will take much longer than the current mission to the ISS. So to provide to the astronauts not only the health and the physical sustain from food, but also the psychological one, we think is very, very important. So bringing with them a little piece of Italy is always something that helps conducting their work. With this, I conclude my speech, and I thank you for the listening. And if you have any question, you can provide them in the chat.
Thank you very much, Liliana, for your very clear and fascinating introduction to the challenges of preparing food for the space mission and for the importance of food for the well-being of the astronauts. And now it's time to learn directly from the star cook Stefano Polato how it is to work with astronauts to prepare food for the space mission. What are the challenges and what are the technologies involved? Chef Stefano Polato has an incredible CV. Before and besides being an extraordinary chef, Stefano Polato is an art historian with a bachelor degree in conservation of cultural heritage and history of art obtained in Venice. He has been working with Arcotec, another aerospace engineering company based in Turin, whose core business is research, innovation, and product development for space application and renewable energy system. Stefano Polato will share his experience on food preparation and how to make it taste good for astronauts. Stefano Polato, to you.
Good evening, everybody, and thank you very much to invite me. So for decades, aerospace research has been producing useful information to improve life on Earth. Many steps forward have also been made on the food sector, especially since missions have become a long-term mission. The experience of a human spaceflight has taught us that aging can be modulated, accelerated, and decelerated. Food represents a tool of fundamental importance to stem the various negative effects of stay in microgravity for the human being. Food no longer represents only a survival factor, but also the support to fundamental importance from a psychological and physical point of view. So Argotec and its team inside the Space Food Lab follow the production of the ESA astronauts bonus food. And from the first mission of Luca Parmitano, Volare, to date, countless steps forward have been made, both from a technological and obviously from a nutritional point of view. The first goal to be achieved in 2013 for the Volare mission of Luca Parmitano was to produce dishes that would serve psychological support, a way for the astronaut to calm down on Earth for a few moments through the senses, and the memory of the typical Italian flavors. In fact, for Luca, traditional dishes were sent to the International Space Station, such as lasagna alla bolognese, Sicilian caponata, eggplant parmigiana, risotto with basil, pesto, and the classical tiramisu. Thanks to the sensitivity and the desire to spread concept of healthy and correct nutrition, again from 2013, the production of functional meal begins with Samantha Cristoforetti. Not only food that was good and tasted, but balanced dishes and practical to eat. To create Samantha Cristoforetti's bonus food, selected ingredients have been used that respect the concept of seasonality, biodiversity, naturalness, and this to support as much as possible an optimal state of psychological and physical well-being for the astronaut. Then to achieve this objective, we selected together with a team of doctors, nutritionists, and dietitians a system to cloud allow the production and to give to Samantha complete meals, which would guarantee the presence of all necessary nutrients properly balanced between them. The basic scheme selected is the healthy eating plate studied by Harvard University, and it's the optimal solution not only for us terrestrials, but also effective in space and very close to the real Mediterranean diet. An example of this is the quinoa salad with mackerel and vegetables Samantha's favorite dish during her mission. A single pouch containing carbohydrate like quinoa, proteins like ginger mackerel, and many vegetables processed in their best season of maturation. And the vegetable was inside the pouch the 50% of the total. Innovative method of processing and cooking of the dishes are still studied and evaluated in order to preserve as much as possible the initial nutritional values. Particular attention is paid to solution defined as athermic. For example, cooking and treatment of food solution that not necessarily require the use of high temperature to create a dish that can be stored at room temperature for many months. In fact, it should not be forgotten that food is in the International Space Station is stored at room temperature. This is the challenge not only for the space food, but also for us human beings. Imagine food that does not require the cold chain, but at the same time provide all nutrients needed for a complete and balanced meal. I think it's beautiful, isn't it? Something very important and not to be underestimated is also the alteration of the senses in space. In fact, in many cases, astronauts have an alterated sense of taste and smell, and it becomes important to ensure the flavor and the taste of the dishes offered. Speaking of which, the purpose dishes always include aromatic herbs and spices, important ingredients not only to ensure taste and fragrance, but also from a nutritional point of view. In 2017, with Paolo Nespoli, with Paolo Nespoli's Vita Mission, we combined the experience gained previously, which means that the traditional dishes have been rebalanced, always following the standards of Harvard University single dish. For example, the classic Bolognese lasagna, where more fiber were added using a wholemeal spelt flour to produce the puff pastry. And saturated fats have been reduced, for example. In short, we have combined the tradition and the innovation following the most recent and current medical scientific guidelines. The experience of Argotech Space Food Lab has taught us that we need a new approach in food production. Cooking, chemistry, physics, engineering, nutrition can not longer work separately. We need a continuous and direct comparison between professionals who must work together to ensure taste, but also obviously healthy. Space research can help us to find effective solutions quickly, even for us who lives on Earth. So thank you very much.
Okay, thank you very much for this amazing. It's amazing to see how behind the preparation of food there is a lot of science. Now, after the theory, it comes the time to talk about the practice of food in space. So we want to talk with those who have been experienced food in space. And I cannot tell you how much thrilled I am to have here tonight with us Dr. Paul Scully-Power. You know, he is the first Australian astronaut, and he has a long distinguished career with unique international background in industry, government, defense, space, academia, not only in Australia, but also in US, UK, New Zealand, with connection all around the world. Dr. Scully Power will explain us why Italian Pinot Grigio is not served in the International Space Station. And I cannot wait to learn why, since you sent me the title. So please join us on the stage. Please.
Well, thank you. Thank you, Anna Marie. And congratulations, Your Excellency, on putting this together. Now, I always thought that the Mediterranean diet, excuse me for being a little dry, but I haven't had much to drink. I always thought the Mediterranean diet was a chilled glass of Pinot Grigio until tonight. So I'm learning. But interesting why I chose that. Oh, what a good man. Thank you. Thank you. Why I chose that subject is I actually have a long history of Pinot Grigio. And I'll give you one story. I'm fortunate enough to know some rich friends who have got super yachts in the Mediterranean. And one day we were in Belle-Île-sur-Mer on the French Riviera, and we ran out of Pinot Grigio. So my host didn't even blink an eye. He dispatched the captain of his mega yacht to go ashore and get some. The captain came back empty-handed, and we wondered why. And he said, well, he was told in no uncertain terms that this is France, it's not Italy, and we don't have Pinot Grigio. So my host, again, didn't blink an eye. And he ordered the captain to leave the port of Belle-Île-sur-Mer and to head east. We went to Sorrento. We pulled in there, and guess what? There was plenty of Pinot Grigio aboard. So that's, excuse me, part of my, excuse me, excuse me. Well, this will work. It might work. Yep. There you go. That's gravity for you. Exactly. Part of my story. But as I say, I've got a long history of Pinot Grigio. Now, I was only in space for 8.5 days, so the folks who have come after me with the International Space Station have had to deal with the issues of food much more than I did. But for 8.5 days, the first 2 days, we just ate fresh food, basically. And then for the rest of the time, we had food that came in packages pretty much like you saw. We'd hydrate them and put them in basically a microwave and eat them. It's just like, excuse me, having a TV dinner. But there's one thing you've got to watch, and I don't think anyone's mentioned it so far, and that is it can easily float off your plate. And if that happens, it's a huge cleanup job. But there's a very simple trick. Now, who in the audience knows what the strongest force is other than gravity here in nature? No scientists in the room. Obviously, it's surface tension. And so if you're eating any of your food, you make sure it's got plenty of moisture in it, then it will stick to your plate, no problem at all. It's very, very simple fix for that problem. And I just want to blow away a few myths. For example, everyone gets on the internet. Everyone gets on the internet and looks up space food, and you see this freeze-dried ice cream. As far as I am aware, I've never seen it, and I've never talked to an astronaut who has. So there's a myth. And one of the things that we just vaguely mentioned was that it's definitely true that most people do lose their sense of, or not completely, but do lose their sense of taste. So for those folks who are worried about preparing food for astronauts, you have to take that into consideration. Now, the other thing that I haven't heard mentioned, but I think is especially for long duration flights is very important, is that everyone has a different metabolism. And I'll give you an example of my own. I typically have one meal a day and have all my life. But when I was in the astronaut office, the bureaucrats religiously took down, what I should be eating. And of course, my diet didn't agree with any of that. And they carefully prepared 3 meals a day for me in space. And I said, I don't need 3 meals a day, I only eat one. And they said, no, you're going to have 3 meals a day, blah, blah, blah. So they loaded up the shuttle with 3 meals a day for me. And I came back after 8.5 days, and I brought back 8.5 days of 2 meals a day. So there are ways of doing it. But it is going to be a tough call to figure out how to have this sort of internal cycle of how you not only prepare food in space, but how you grow food in space. And as we go for longer and longer missions, that's going to become a real issue. And certainly in thinking about a trip to Mars, I, for one, have no idea how we're going to do that. I know we've done experiments and so on and so forth, but that is going to be a terribly difficult ask. Now, why is there no Pinot Grigio on the ISS? Well, I can tell you, madam.
I'm waiting.
I was in the astronaut office. Well, first of all, in the early flights, of course, no one even bothered about it. But when the US started to have international astronauts, one of the earliest ones was a Frenchman. And he, of course, requested that they have some nice wine on board. And the American bureaucrats, of course, totally rejected it. So I went into bat. I tried to get that decision reversed, but I have to admit I failed. But when you think about it, with these long duration flights, everyone is mentioning today the psychological effects. So perhaps one should think a little broader and say, well, maybe if we had Pinot Grigio on board, we wouldn't have so many bad psychological effects. So, Madam Ambassador, I stand here saying I'll support you in your efforts to get Pinot Grigio aboard the International Space Station. And I'll leave you with one thought. I talked about the foods that I didn't eat, but I did make history because I took a food with approval to space that had never been taken before. And that was M&Ms. You know what M&Ms are? And I was able to get them and throw them up, and sort of they'd float around the cockpit, and I'd go like a little groper and go eat them up. And I even have a video to prove it, but unfortunately I don't have it tonight. But I really thank you all for inviting me, and I'll be around so we can chat a bit later. Thank you very much.
Well, thank you very much, Dr. Paul Scally-Power, and thank you very much for accepting the invitation and also for all the spirit you put in the presentation. And finally, to round off, and in Italian we would say dulcis in fundo, I'll have the privilege to introduce the Italian engineer and senior astronaut Paolo Nespoli. Paolo Nespoli flew his first space flight in 2007 on a short duration mission to International Space Station. And in 2010 and 2011, he took part to a long duration mission in the International Space Station. And then he flew again to the station just 3 years ago in 2017. He spent 313 days in the International Space Station, and as a first-hand experience of both the experiments that are run on the station on growing vegetables in the microgravity, and on how it is living and eating for almost 1 year in a unique confined environment of a space station. Engineer Nespoli, you have the floor.
Thank you, Anna Maria.
you can hear me, right? And good evening, everybody. It's just a pleasure to be here with you. I would like to thank Her Excellency Ambassador Tardioli for organizing this event. I would like to thank Anna Maria, of course, and I would like to thank everybody there, including my colleague Paul Scully Power, with his amusing and interesting talk about Pinot Grigio. Still off today, we don't have Pinot Grigio in space, which is kind of interesting. It's kind of difficult to move the space station from where we are, go east and try to land in Sorrento. We would love to do that if that would be easily possible, but I think it's not quite easy at the moment. In any case, um, I would. I had prepared a couple of slides here, which I was going to talk about it. And let's see, here we go. Because we already saw a lot of this food. This is the initial food that was prepared for the Mercury and Gemini food, and then it kept going with a little bit um, more prepared until we end up on the Skylab and eventually on the shuttle food, which essentially is what we usually use today on the space station. Because what we have heard so far is that, yeah, we do need a food, and it's very important for a survival factor to have the right food at the right time at the same time. I think the problem here is that we are up in space to work, and therefore, let me see. Yeah, let me go back again. So these were part of the food that is today. I would say that 75% of the food that is produced and available in space is actually coming from the ground. And as Loredana, sorry, Liliana, so I kept calling her. I don't know why, Liliana. Sorry, I keep calling her Liliana, Loredana. See, I'm getting confused. I'm sorry. But 75% of the food is today essentially the standard food, because NASA wants to have a standard size of food available there. They have to have this food. Otherwise, what they're going to do, take you back home because the food is finished. So they have to bring it up, and about a quarter, and the rest of the food, about a quarter of the food is then produced by what is called bonus food. And this is what we were talking about before: bonus food. Bonus, not just because it's bonus, but it's because it's a special food dedicated to that specific astronaut, which of course, if he comes from Australia, may want to have some Vegemite, but if he comes from God knows what, and the first time I was in Australia and they gave me Vegemite, I look at them like, what is this thing? And they're like, oh, but this is like your chocolate thing, which is maybe very interesting for somebody from Australia, but from somebody from Italy, you may not miss it for the 6 months you are in space, or the 8 months you are in space, or the year you are in space. So the bottom part is that the bonus food, it's very, very interesting because it's the only food that can be very nicely tailored to the tanks. I'm just going to look for the picture, because essentially I'm looking for the previous picture. Uh, it's very, very interesting. Okay, in fact, what we do in space is that we are actually working from 7:30 in the morning until 7:30 in the evening, and therefore we are busy in trying to execute a science protocol, which requires results. And this is what you are in space to do. What in space, you're not just there passing by, I'm passing by here, what can I do today? I can just handle some experiment. You actually have to do exactly what they tell you to do at the exact time. Some experiments have a little bit of leeway, some not, but normally yes. So the bottom line is that NASA and anyhow every space agency need to have enough resources there to be sure that the astronauts are able to conduct that experiments and produce the results, which are the ones that are actually needed on the ground for the science to produce to verify the results that they want to verify. And that's the reason why you send in space and you send an experiment in space. So the bottom line is that you need to find a way to have an environment up in space so that for 6 months you can actually carry out your work and produce the results that they are looking for. It's very interesting because you can do this. You can push through a day or two or a week or even a month if you really push hard. But it's going to get really difficult without Pinot Grigio for a long time. And that's why I really like the discussion of Paul Scully about where is the Pinot Grigio? I need the Pinot Grigio to work because in fact this is something that NASA is not really at the moment considering completely, because they think, well, you don't have a little bit of Pinot Grigio, it's fine. You just clench your teeth and you just keep going without Pinot Grigio. But that's not the point. The point is to allow an environment there in space that allows you to have a little bit of rest, but at the same time, being able to put in all the energies, all the necessary steps, all the necessary parts to be able to carry out your job, and that can be kind of difficult because you can do it for a few days, as I said, for a couple of weeks, but then even a month can be really complicated, and that's why NASA eventually decided to leave 25% of the food that we bring up in space, leave it to the choice of the astronauts, and so that he or she can bring up food that is reminding him or her his own origins, and even organize, as I was doing with the food that Stefano Argotec, Altec, and everybody in Italy provided me. Once in a while, I was calling everybody for a meal on board, and I would call it an Italian meal, and it was really interesting. In fact, I would like to even close this with a show because at a certain point I did. There we go. I start going again. At a certain point, I started. There we go. In a video conference, I was talking to a manager of the space station, and I said the food is really good here, but we are really missing a pizza. And so what they did, they sent up in space some items to build. To allow us to build a space. I'm not quite sure why they send us four pizzas while we were 6 people. I'm not quite sure about that, but that's the way they were counting. So it was kind of interesting. You can find that video in YouTube, by the way, if you are interested. And it was an interesting way because it was just one evening we played around with this pizza for an hour or something, and it was very funny because this is not something that you see every day in space, and that helped us to kind of refresh our attention and focus on the important part, which was to actually carry out the experiments and produce the results that they were looking for. Anna Maria, I think I'm done here. Thank you. You have a place.
Here,
Go ahead,
yeah.
go ahead.
Just a second. Okay, so thank you very much for accepting the invitation. And yeah, it has been really, really interesting to listening to you again. And now I trust that all speakers greatly contributed to raise the appetite for the food in space, including science, technology, and taste. And I would like to open the floor to questions from the audience. And then we have people also in Zoom. We have 53 people in Zoom now. So while my colleagues check the question on Zoom, I would like to have question from you. But first, I have a question for Paolo Nespoli, if I still have it. So based on your experience, hi Paolo, no, hi Paolo. Based on your experience, how feasible it is that we will have a colony on the moon soon?
Well, Anna Maria, colony is a bad word to start with. Everybody that asks me about how should we colonize, I simply say we shouldn't. Colonize, it's a bad quote unquote word that was used in the past to go somewhere, grab all the resources, enslave everybody and go back. So I hope...
Wait a second,
yes.
we have a problem with the voice. Okay, go on.
So I was saying, Anna Maria, that colonize, it's a word that has some kind of historical background that I would think we should not use because colonize meant in the past. Can you hear, Anna Maria?
Yes, I can. I just
okay,
was saying that I agree with you.
Oh, okay. And so
wrong choice of word.
It's not the best word. What I would say is that we need to continue our exploration of the universe. And if we just understand that we know one grain of sand of all the grains of sand of all the beaches of the whole universe, we know that we know nothing. I mean, we have so much to learn. Maybe all the other grains are the same. Maybe yes, maybe not. I'm not quite sure. But it's going to take quite some time for us to be able to have an outpost on the moon. I think we will be able to go fairly soon. But I think even if we go to the moon, we still have a long way to go before expanding ourselves in the universe.
Okay, thank you very much for this. Now, maybe we start then with the Q&A from people in Zoom, but I can't read them. So, Rachele, it's your turn. You are the one in charge.
Thank you. We have a few questions. The first one is, how do you heat up your food? Is it a microwave or something more complex?
Could you hear this?
Yes, I could. I heard Dr. Paul Scully talking about the microwave earlier, and in fact, we don't have a microwave on the space station. We have some kind of plate which is heat up with a little heater, and then those plastic bags are attached to that plate. This is what we use now. It's very inefficient, to be honest, but it works, and I think it's compatible with the requirements of keeping low temperature objects on the space station. In the future, we will have to find a different ways. We just need to find different ways. That's
Okay, thank you very much. Other questions? No. Filippo, would you come on stage for your question? It's easier if you come here.
Thank you. I have a question actually for Dr. Battistelli. And perhaps with Dr. Ravagnolo as well. It's we know that the first living being that was ever brought to space was a dog, Laika. Although I believe it wasn't the real name of the dog, but anyways, haven't you considered? So and the dog lived for I think a few hours at least. So have you considered also a live food stock and the possibility to maybe fish eggs that could hatch in space, in a space environment, which of course is controlled also because water of course also changes the gravity, the concept of gravity in space? Thank you.
Alberto, will you proceed first?
Or Liliana?
The animals are brought to the, and other organisms actually are brought to the International Space Station for experiment, even mice, for example, and they are even brought back to check their health status now, so they are not leaving to die in space. For the bioregenerative life support systems, for example, we are now studying how to recycle waste. You know that waste in the International Space Station is just brought back toward the Earth and it's burned in re-entering, which is not a circularity approach to waste. We are studying how to recycle waste, and in collaboration with another public research entity, ENEA, we are trying to grow flies on waste. So in the future, if we have outposts, we need to join other organisms and to share space and the environment with them.
Okay, thank you very much. Are there any other questions from the Zoom?
There are a couple that maybe we could read together and reply at the same time. So one is, astronauts have a lot of things to do during the day. How much time is dedicated to meals? And the second one from one of the students is, how often do they send a new load of food to the ISS? What type of food is the most rated from astronauts? How much does it cost to the agency?
Okay, Paolo, I think it's for you, the question.
Well, I can answer.
Please hold the microphone.
Yes, can you hear me better now? Yes. So we do have about an hour of lunchtime and then some time for breakfast and dinner. The breakfast and dinner, you actually decide how much time you want because it's in your private time. I would say that in general, we do spend about an hour and a half or an hour in food eating. It depends what you want to do. Sometimes it's quick, sometimes it's less quick. It depends. You know, if there is a dinner, for example, on Friday night or Saturday night, we might have a social dinner. Then we actually spend an hour and a half, and then we'll watch a movie. So it depends a little bit.
And
one more from the Q&A, and then I believe there is something in the chat. Austrians have to spend money to go into the station, or is all the expense of the state?
Do you pay to go to the station, or do they pay you?
Well, actually, this is an interesting question because, in fact, I would say none of the two. You don't pay and you're not paid. There is a little bit of additional money which you get because if you're on the ground and you travel, you actually get a little bit of money for the hotel and this kind of things. But since this is all given, they start giving you the whole amount, and then they subtract, and as far as I remember, I think I got something like $3 or $4 US dollars a day, which is interesting, but it's nothing that it will really pay you for going to space and make some money.
But I think you had the most beautiful view from there than any other people. True. So is there any question from the floor? I would like to, yeah, please come here, because it's much, much easier this way. That bring the microphone there. Yeah. And
thank you. My question is probably a little bit distasteful, but I was really curious. We were talking earlier about the prebiotics, and it occurred to me whether it was possible for astronauts to contract food poisoning in space, or do the effects of being in space change digestion and cause food poisoning-like problems for astronauts, and how do those get solved?
Paul Scally-Power, do you have any answer to this question? No. No. So let's go back to Paolo. You need to turn the microphone.
Yes. Yes, of course. This is one of the major problems there, and that's why Liliana was mentioning earlier that the food needs to be eaten in 2 years, because that's the usual amount of time that food is kept or can be kept in an eatable state. You could get some sort of poisoning. We did find out of the 6 months we were in space, we found 2 or 3 packages that were kind of not sealed properly, and they had been contaminated. We could not really figure out if there was contamination or not, but we had enough food so that we took pictures and then destroyed the packages. But that's normal. I would say it's almost normal. You know, once in a while, even here on Earth, you go to the store, buy something, and then you come back home and you find that it's either spoiled or not eatable. So I think it's in the norm.
Yeah. Liliana Ravagnolo, do you have any comment on this?
Yes, I think that on Earth, we that produce the food, we do our best to support all the requirement and to prepare the menus and stabilize them according to the rules that are established. But obviously, as it was said before, the fact that the food is transported to the launch pad, and then it's stored there maybe for months before leaving the Earth, and all is at room temperature, at ambient temperature. It can create some problems. So we are all working to avoid this kind of things, but it's something to be taken into consideration.
Thank you. Eduardo Trifone is coming with a question.
So my question is simple: do you expect the commercial access to the International Space Station will increase or can increase the amount of bonus food or fresh food to the International Space Station?
Who is answering? Maybe Stefano. I have any idea? Your microphone, Stefano, is off.
I'm sorry, but I can't hear the question. So if you can repeat, please.
So the question was, with all the new Do you expect to have much bonus food with the increasing of flight to the station?
But I think it's a question for Paolo. We hope that the bonus food will increase in the future. But as I said before, by Paolo Nespoli, NASA and Russia agency would have a standard food in major quantities. So it's a sort of a political decision, I think. So we hope, but we are restricted at the moment.
Okay, I have one question now for Battistelli, and is what is the level of technology required to put in operation the greenhouses that you were talking about?
Thank you for the question. When we make experiments and we build things on Earth for use on Earth, we have a very high technological level, but still very low with respect to what is required for space. So the step to go from Earth material to space material, it's huge, even in terms of costs. So what we have done up to now is Earth-based. The NASA is just setting up a new system for plant growth on the International Space Station, which is this size, more or less. So the steps forward are huge still, but then we have time. I think we have probably 10 or more years. The problem is that when you do things for space, you need time. You need time, you need resources, and you need to test and fail and do it again. By now, one new aspect of the space activities is entering of private companies, and that speed up a lot, many things. So we don't really know when, but we know that we need to spatialize things that we have already tested, and that will cost a lot of effort and a lot of resources. I think that we also have to demonstrate that it's convenient. It's convenient to bring there all the material and technology needed to produce what we will avoid to bring them from Earth. And this is a lot of work to be done. That's why I stress the fact that we need young people to enter the game for the future.
Okay, thank you very much. One last question, I think.
Liliana, are you permitted to talk about the Wake project? Wake.
Liliana, did you hear the question?
Sorry, no, it's impossible to hear from here.
Yeah.
Can you repeat, please?
This one, I don't know if you can read it from the probably it's easier. Liliana, are you permitted to talk about the Wake project?
Can you see the question on the screen?
No.
I can't read it. Are you permitted to talk about Wake project?
Oh, okay. It's not. It's a project that we are working on. It's not strictly related to food. That's why I didn't mention it. Is related to virtual reality and augmented reality for training. So the scope is to develop new tools that can help the astronauts to become more autonomous and independent when they will go to long duration mission, exploration mission to the moon or Mars. And the reason is that nowadays they spend about 18 months to 24 months for training on Earth for a mission that lasts 6 months. So if we imagine that the mission to Mars will last years, it will not be possible to spend the same amount of time in training. So the idea is to give them some procedures that are performed by the instructor using virtual reality, and they will have to run these procedures just before the operation they will have to conduct. So this is, in very synthesis, the scope of the WAKIT project. So it's not related with food, I'm sorry.
Okay, thank you very much. I think we have finished now with the time. I would like to thank all the speakers that have taken part of this evening. Before leaving, I would like, can I ask you, Filippo, can you turn around so that our speaker can see that I'm not the alone here speaking with them, but there is a lot of people, almost 80 people here. And yeah, good, thank you very much. So 50 are via Zoom and all the other are here in this beautiful place in the university, Australian National University. So, and before also saying goodbye to our speaker, I would like to thank our only speaker in presence with a little souvenir. Can you please come on stage with me? Yeah, yeah, there is an explanation.
I think I know what
yeah,
it
just,
is.
If you were here, Paolo, you would have had yours. So, of course, one is quite obvious. I guess what it is. Guess what it is. This is a Pinot Grigio. No, don't go away. Don't go away, because there is a special prize, which is for an astronaut. The night. Wait a second. Too much. See what is this? Yeah, this is the Nights of Galileo. So going back to space, this is, you know, the night of, no, you know Galileo, but not the night of Galileo. And yeah, you need a bag for this, a special bag, of course. But thank you very much for, thank you very much for coming, and thank you all. I wish also to thank all the people that followed us on Zoom, in particular the students of Novi Ligure. Thank you for being with us. Thank you for the teacher that introduced them to this webinar. And also I need to thank Ivana, who came here to help us, Lorenzo, Rachele, and where is Anna Fortuzzi, who really helped me putting on this, beside the embassy, of course. So I wish to say goodbye to all of you, and we will meet again soon. Bye.
Thank you, bye.
Thank you.
And now that is closed.